This is about geometry and how you fit different shapes into different shapes, squares and circles and triangles. The Ordnance Survey map has grids which cover the whole of Britain in grid squares. You can see the lines going along and sideways. Now the circle I've drawn is just over the size of a square, which is made up of 4 units here I've chosen. So we'll call a unit 100 because that's what the Ordnance Survey uses. So the square is 100 in both directions, here and here, 100 square, and the circle is 101. So round the nodes, which are the points of 4 where they intersect, if you have a point on each side of the circle, it will be longer than the nodes but shorter than the diagonal across there, which is 1.41 larger because of the geometry of a square. So my question was, with this Ordnance Survey map showing the red splodges where people have taken photos, in this case me, I wanted to know the equivalent. So you'll see that my photos spread beyond the lines here, but the question is, can you fit my particular splotches, which are completely random obviously, within the diagonals of 4 squares, so that whichever way you rotate it they will fit in 4 squares. Now I didn't actually know the answer to this, so I experimented with cut out pieces of paper on the grid to find out the answer, and it's actually quite simple, because as you'll see, the circle here shows every possible point which is on the line which is larger than the square. Now if you have somebody who's visited the entire circle, whichever way you rotate it you can see it will extend beyond the 4 squares, even though none of it is larger than the diagonal. So that is what I call a paradox, a mathematical paradox. So my question was, what is the minimum number of red splodges you have which will go beyond the 4 squares, so whichever way you rotate them it'll be impossible. So you can turn it round and round and round, but only with 3 points. Obviously if you have a point there and you have a point there, as soon as you rotate it the other way it's going to go back into 4 squares. So I did it the manual way because I can't do maths and I don't know the formula, by cutting out a triangle. So the formula is very simple, which I discovered. The maximum points, say the maximum point would be there and there, which clearly goes outside the circle but fits within the 4 squares here, whichever way you rotate it. So my question was, do you need 3 or more spots slightly outside the circle which will never be able to be rotated to fit in the 4 squares, even though the distance is below 1.4 units from the maximum? And the answer is yes, because obviously it has to be yes, because the circle of all of them can't be rotated to fit inside the 4. So the answer was actually very simple, because I used it by cutting out my own 3 triangles of the furthest points. The furthest one there is Dover, the furthest one there is Cheltenham, and the furthest one there is Chippenham, which all fall way outside the 4 squares as they are. Now if you were to take a photo of this, put it on transparent plastic and rotate it around, you would actually prove the point that they're not quite spread out enough to do the job, and they will still go within that square of 4. However, if you go from Chippenham to, well, about there, which is maybe 10 miles southwest of Chippenham, you will end up with a little triangle which goes from there to there to there. Now whichever way, I should have cut one out to show you but I forgot, whichever way that triangle goes it will not be possible to fit within the circle, and as far as I know it's a unique solution. There is one triangle which is slightly too big, and that is the minimum area of a triangle with the shortest 3 faces that you need to rotate, and that is a triangle which starts there, has a point just outside there and finishes just over there in the corner. So that's one corner of 4, so ignore the circle now. We're looking at the 4 squares one point of the triangle would be there when rotated, one would be there, which is at the far top of that square, and the other one will poke just outside that, so it'll still be below 1.4 units, but quite enough. And you'll find that if you turn that triangle round any way you like, it won't fit in the 4 squares, even though it's shorter than the diagonal. I hope you understand that. Thank you.